Okay, now we'll build up the nullclines for our vector field. So a nullcline is a curve where one of the components of the vector field is 0. And we can use this to help sketch a vector field. So if we have a nullcline for x prime of t, that's where x prime of t equals 0. That means there's no horizontal component. And so the vectors point up and down. Nullclines for y prime of t, that means there's no vertical component, so the vectors point left and right. So we'll find the nullclines, for example, and sketch the vector field with the aid of the nullclines, and then the linearized equilibrium. So x prime of t is 10x minus 5xy. We have no left-right component, right? X prime of t equals 0 for x equals 0, y equals 2. And remember that we actually solved that equation back when we were looking for equilibria. We set x prime of t equals 0. We get x equals 0, y equals 2. And remember that in 2 dimensions, these are lines, right? These aren't points. X equals 0 is a vertical line, y equals 2 is a horizontal line. So y prime of t is 3y plus xy minus 3y squared. And we want to know, along the nullclines, what is the sign of y prime of t? So we take our nullcline x equals 0, we plug that into this. We get y prime of t is equal to 3y minus 3y squared on the nullcline, because x equals 0. And we can rewrite that as 3y times 1 minus y. And we can do a sign chart, or you can recognize this as a parabola. There's a number of different ways to figure out the signs. But y prime is less than 0, for y less than 0. Y prime is greater than 0 for y between 0 and 1. And y prime is less than 0 for 1 less than y. So x equals 0 is the y-axis. So I'll draw the picture down here. Scroll that up a little bit. So there's the x-axis. We'll draw that's the y-axis. We'll draw the x-axis in a little bit later. This is a nullcline. X prime equals 0 on that. So all our arrows are up and down. Down, right? Y prime is negative, a negative y component. If y is less than 0, up for y between 0 and 1, and down again for y greater than 1. And remember, we had 3 equilibria. One was 0, 0, and one was 0, 1. And down there, up here, and down there. So along the vertical axis, we have that. And now the other one we want is, what's the sign of y prime of t when y equals 2? Right? That's my other equilibrium. And if we plug in y equals 2, we get 6 plus 2y minus 12, oops, 2x, the 2x there, which is 2x minus 6, which we can rewrite as 2x minus 3. So what's the sign of y prime? Y prime is less than 0 for x less than 0. Y prime is greater than 0. Sorry about that. We need to rewrite this. X less than 3, because this equals 0 when x equals 3. Y prime is greater than 0, 3 less than x. So y equals 2. That's y equals 1. y equals 2 is up here. Remember, we have another equilibrium out there. And there's our null line. And y prime is less than 0 for x less than 3. So all along this part, our arrows point down. It's nice that they match up here. This again is x prime equals 0, and all along here, they're going up. Right, and note, of course, that your equilibria have to lie on the nullclines, right? Because equilibria is where both components equal 0. One of the components is equal to 0. That gives me a nullcline. Equilibria have to lie on that. Great. So that gives me arrows. The nice thing about these arrows is they tell us what solution curves have to do. For this line, for example, here, all the way up till we get to this equilibria, whatever solution crosses this line has to do it going down, right? So it really restricts what solutions can do. The other thing to note is that this vertical line is itself a solution because these arrows are actually tangent to that line. So this is a solution, this is a solution, and that's a solution. There's actually 1, 2, 3, 4, 5 solutions on that vertical axis. 3 ones with arrows and then 2 equilibria. And the other thing to keep in mind about vector fields is that solution curves can't cross. So a solution, right, the y-axis now acts as a barrier, right? There's solutions on one side, solutions on the other side, but they can't cross the y-axis. So what about nullclines for y prime? And that's 3y plus xy minus 3y squared. And remember that we solved y prime of t equals 0 back when we were solving the equilibria. And so that meant either y equals 0 or y equals 1/3 x plus 1. So what's the sign of x prime of t on the nullcline y equals 0? Remember that on this nullcline, there's no vertical component because y prime is 0, so there's going to be a left-right component. Right? And x prime of t is 10x minus 5xy. So on the nullcline, y equals 0, x prime of t is 10x. Sine of x prime of t, x prime is less than 0 for x less than 0. X prime is greater than 0 for x greater than 0. So our nullcline here is the x-axis. This is a nullcline for y prime equals 0, and all the arrows are left and right, and they're going to the right for positive, and to the left for negative x. And now our solution curves, our x-axis is also a solution curve. There's 3 solutions here. There's one that goes out to the left here, is the equilibrium, and then there's one that goes out to the right. And again, no solutions can cross that. Now the last equilibrium is nullcline, is sine of x prime of t on y equals 1/3 x plus 1. So again, x prime of t now is 10x minus 5 times x times 1/3 x plus 1. So we substitute 1/3 x plus 1 in for the y. We get this, which if we simplify it, becomes 5/3 x times 3 minus x. And that's a parabola. It opens down, so it's going to be negative for big values of x and positive in between the. So for x less than 0, x prime is negative. For x between 0 and 3, x prime is positive. For 3 less than x, x prime is negative. And again, you can do that with a sign chart or just by properties of parabolas. So on y equals 1/3 x plus 1. Now 1/3 x plus 1 goes through this equilibria and that equilibria. So this is my other nullcline for y. And it goes negative, positive, negative. So we have pointing to the left, which is nice because it lines up there. Points to the right here. And then points to the left here. Great. And note that our equilibria are all at places where a nullcline for x prime and a nullcline for y prime cross, right? This one is on this curve for y prime and this curve for x prime. This is a y prime equals 0. This is an x prime equals 0. This point here is where two nullclines cross, but they're both for x prime equal to 0, right? So that's not an equilibrium because y prime is not 0 there. Likewise, over here, this is where two nullclines for y cross. That's not an equilibrium. So that gives us a little bit of a picture of what our solution curves should look like, right? They're coming down here, it looks like, coming down this way, and then they rotate out, and there's that spiral that we think is going on there, coming out here this way. Not quite sure what's going out here, but down, down, out again. So it gives us a little bit of a picture of what's going on. So the nullclines are very useful because they can help us sort of structure the vector field. Remember that the components can only change sign where something is 0. So for example, x prime is 0 on this line here and on this vertical line. So that means up in this area here, right, the x components all have to be pointing in the same direction. And we know that they're pointing to the left because we have, in this quadrant, we have some arrows that are pointing to the left. So all my x primes are pointing in that direction up in here. Up in here, we don't quite know what direction they're pointing because we haven't gotten any arrows there. Here, we know in this quadrant down here, we have that all your x prime arrows are going to the left, and in this quadrant here, they're all going to the right. So the nullclines actually put a big structure on your vector field because in the regions boxed out by the nullclines, the arrows can't change sign. They all have to be pointing in the same direction. So that's a little bit about nullclines, how to graph them, and what they look like. And then we'll put all this stuff together to get a picture of our vector field.